Ever wondered how a missile moving faster than Mach 10 can be detected, tracked, and destroyed before it even reaches its target? Today on Knowledge Hub, we're diving into the invisible shield that protects nations, and how radars, satellites, supercomputers, and interceptors work together in seconds to destroy a threat. When a ballistic missile launches, it doesn't just disappear into the sky unnoticed. The first thing that gives it away is heat. During the boost phase, its rocket engines produce an intense infrared plume visible from space. Early warning satellites equipped with infrared sensors detect this almost instantly. But detection alone isn't enough. Ground-based and sea-based phased array radars then lock onto the target. Unlike traditional spinning radars, modern active electronically scanned array systems steer beams electronically at near light speed, allowing them to track multiple objects simultaneously with extreme precision. Systems like the Aegis combat system and the Patriot rely on this radar technology to create a real-time 3D model of the missile's trajectory. Now here's where it becomes computational warfare. The system calculates velocity, altitude, acceleration, and predicted impact point using ballistic modeling equations. If the missile is heading toward a populated area or strategic target, interception is authorized. Some systems, like the Iron Dome, are optimized for short-range rockets and artillery. Iron Dome's software predicts whether a rocket will hit a city or land harmlessly in open ground. If there's no threat, it doesn't waste an interceptor. That's not just engineering, that's algorithmic efficiency. Missiles typically travel in 3 phases: boost, midcourse, and terminal. The boost phase is short but highly visible due to engine burn. The midcourse phase happens in space, where the warhead coasts along a ballistic arc. This is also where attackers deploy decoys, lightweight objects designed to confuse radar systems. Missile defense radars perform discrimination, analyzing radar cross-sections, object behavior, and infrared signatures to distinguish the real warhead from decoys. Then comes the terminal phase, when the warhead re-enters the atmosphere at hypersonic speeds. At this point, defenders may have less than a minute to respond. Interception itself happens in 2 primary ways. The first uses proximity-fused explosive warheads. The interceptor approaches the incoming missile and detonates nearby, destroying it with high-velocity fragmentation. Patriot uses this method in many configurations. The second method is hit-to-kill kinetic interception. Systems such as terminal high-altitude area defense rely purely on physics. There's no explosive. Instead, the interceptor collides directly with the target at extreme speeds. At Mach 8 or higher, the kinetic energy alone is enough to obliterate a warhead. It's essentially a high-speed collision calculated with centimeter-level precision, sometimes in the vacuum of space. Modern missile defense is layered. Short-range systems defend against rockets and drones. Medium-range systems intercept cruise missiles and tactical ballistic missiles. High-altitude systems engage long-range ballistic threats. Naval platforms equipped with Aegis extend protection across oceans using standard missile interceptors capable of exo-atmospheric engagements. This layered architecture increases the probability of interception by providing multiple engagement opportunities. Behind the scenes, everything is connected through secure command and control networks. Data from satellites, radars, and interceptors flows into centralized battle management systems. Advanced algorithms process the data in real time, recommend engagement solutions, and coordinate launches. But despite the automation, human authorization often remains part of the chain because the consequences are strategic. And here's the reality. Missile defense is an ongoing technological race. Hypersonic glide vehicles can maneuver unpredictably within the atmosphere. Electronic warfare can attempt to jam sensors. Decoy countermeasures continue to evolve. Each advancement in offensive missile technology pushes defensive systems to become faster, smarter, and more precise. So when you see a missile intercepted in the night sky, remember, nothing magical happened. No invisible force field. Just satellites detecting heat signatures, radars calculating trajectories, supercomputers solving physics equations in milliseconds, and interceptors colliding at hypersonic speed. It's synchronized engineering at the edge of possibility. If you have enjoyed breaking down how missile defense systems stop hypersonic threats in midair, make sure you subscribe to Knowledge Hub for more deep dives. And as always, stay curious.